Inspired by the current coronavirus pandemic, REEN Biotech has worked tirelessly in the past 7 months to develop a compact and portable device that can sanitize surfaces autonomously in high-traffic areas. And today, we are proud to present our Dual UVC Pods.
Hi, I'm Lydia Dominguez.
Hi, I'm Francesca Noriega.
Hi, I'm Gabriela Rico.
Hi, I'm Emma Schoeneman, and
we're REEN Biotech.
What was originally just a SolidWorks concept quickly became a physical prototype via 3D printing machinery. Entirely built from ABS plastic, ABS plastic is the ideal choice of material for our device considering its mechanical properties and intended use of our device. The device features 4 slots for each LED, 1 large slot for the motion sensor, as well as a snap latch back door for easy access to the internal components. Our team, entirely made up of biomedical engineers, had no previous experience with electronic circuits. Therefore, REEN Biotech gathered support to develop a complete electronic circuit board from the ground up. Through the long weeks, it was imperative to test any and all components, and then test them again and again. We began testing each individual LED bulb, and then again in parallel. With confidence, we tested with a motion sensor, and finally the whole shebang, LEDs, motion sensor, and a setup on a breadboard. After we knew the LEDs powered on with any detected motion, we installed a code that powered the light for 10 seconds but cuts off if there is any other motion detected. Because UVC radiation poses a threat when contact to the skin, we want to minimize any exposure for the user. Ideally, in its full and complete prototype, our Dual UVC Pods will encompass both sides of its target surface, such as above and below a doorknob, and proceed to sterilize the area it surrounds with the use of UVC radiation as seen in germicidal ultraviolet applications.
Okay.
Our code was finally perfected, and from here it was time for the real deal. We quickly got to work and began to solder each component to a printed circuit board.
Let's take a look inside of our first prototype. It is currently very full and messy, but we will be replacing the Arduino Uno with a microcontroller and the breadboard with a printed circuit board. Now let's take a closer look at each individual component. So the components inside of our device include the UVC LEDs, but for now we are using regular LEDs. Then we have a lot of jumper cables that are connected to the breadboard that are then connected to the Arduino that has our code that controls the whole device. And then we have a 9-volt battery to power the device. And finally, we have our PIR motion sensor that sends the signal to power the lights.
Here is our device in action. You reach for the door, and almost immediately after your hand leaves and no more motion is detected, our pods get to work. For our device to work at its best, the target surface, in this case a doorknob, should have a pod above and below to encompass the entire surface area. And aforementioned, if you reach for the doorknob and someone follows when the lights are on, they will immediately cut out to prevent harmful exposure. Thanks for watching!